Okay, so for our fourth video to wrap up this problem, we're going to now take the values of a, b, c, and d that we found from our graphing calculator and rewrite our partial fraction decomposition using them. So big Y of s is equal to negative 47 over 25 times 1 over s minus 1 plus the b number, which is 26 over 25 times 1 over s minus 1 squared, plus our c number, which is negative 3 over 25 times s over s squared plus 4. And then finally our d number, minus 8 over 25, 1 over s squared plus 4. And we're almost ready for the inverse here, except you'll notice that last term is going to be a sine inverse, but because of the fact that we have a 1 up there and not a 2, we have to multiply the top and bottom of this by 2 to make sure that we can take the inverse. And then that extra 2 down there, and that 2 will make a 4 when we go ahead and take the inverse transform. So now taking our inverse, we're going to have y of t equal negative 47 over 25 e to the t. And then our second term is 26 over 25, and that is a shift from an exponential. So that's an e to the t times the transform inverse of s squared, which is t. So that is e to the t times t, or vice versa, t e to the t. The next term is going to be negative 3 over 25 cosine of 2t. And then finally, the last term is negative 4 over 25 sine of 2t. And you will notice here that if you go ahead and check your initial conditions, if you do evaluate y at 0, you do have negative 47 over 25, minus 3 more over 25 makes negative 50 over 25, which is negative 2. So this solution does satisfy the IVP for the initial value. And you could take the derivative and plug in 0 as well to check out the second initial condition. So, and you'll also notice that if you look back on previous chapter 4, this looks like our case that we saw where we have the particular solution, which is the last two terms here because of the cosine. And this right here, the first two terms, is our homogeneous solution if we would have had just the equation equal to 0. So it's nice to see that we now have a second way to solve our second order initial value problems.